voice. Today I will talk about an article written by Professor Hamdard Jabri from Qatar University. Their work is published in a recent number of fermentation and review and is entitled Microalgal Feedstock for Biofuel Production, Recent Advances, Challenges, and Future Perspective. The work is telling about recent achievements of microalgae using for replacing conventional fuels. The work illustrating advantages, why it's important, and because extraction, green extraction that really serve in this part, and green and zero waste emission are the priorities of European Union and United Nations. There is sufficient to promote this. The fossil fuels are lack, and therefore the most low energetic part of this macro is using organisms like bacteria, algae, and microalgae. The work of Professor Al-Jabri is focusing of transferring these microalgae into bioethanol, biodiesel, biojet fuel, biohydrogen, methane, bio-oil, different part, and how what assess challenges. He very little says about economics, but as ideas, he's saying that, however, Paris Agreement and Kyoto Protocol is rising, and in case of our 20 years, growth in case by 3 Celsius instead of 1/2, so the efforts are very inefficient. It needs great increase. There is few examples of black liquor and plants and microalgae that can be transferred, beside being substrate for biofuel, also reduce greenhouse effect by capturing very efficiently carbon dioxide. The other position advantage and using is that they can be using for fiber absorption of heavy metals. Therefore, we can reduce as heavy metal pollution, and the waste that is not used can be used for in different kinds, especially thermal, can be used for production of polymer, which is green polymer would be suitable. There are many points from microalgae, sedimentus, chlorella, tunarella, and spirulina, especially nano, are used, and these first different biofuels are described. Firstly, as bioethanol, which can be produced also for algae, containing biomass when its transversion, the sugars and sugar part of this plant. And these can use yeast cell, so similar to using a brown word and a white word. But there's a special yeast and which is using to produce ethanol. But some side products are butanol, which can be also very useful, especially as both in addition to fatty ethyl ester can be good using for diesel replacement or ethanol and for trucks and ships. This is part, ethanol and flame are important of oil, yeah, which is used in biojet fuel, which is already can be used in was used in Japan and in Canada due to is added more often due to lower higher icing properties. There is first part using bioethanol. We can take the seawater, they say about seawater most, wastewater, the nitrogen and sun, they capture some carbon some dioxide, therefore is growing, and then these microalgae after cultivation, they are catching, harvesting, after giving some unit for some filtration, they are treated in many times, acidic, alkali, and some mechanical. Yesterday I was talking that most in case is in case of pyrolysis, yes, 2 days ago, pyrolysis, and this was much better by using some thermal and acidic are more less enzymatic are more required. So use as hydrothermal hydrolysis are better than other, but more useful, much more apparatus is needed utilization, and this what is pretreated, some after which is containing cellulose can be by saccharylation and fermentation, and other parts separation can also be fermentation, and then after distillation we have high bioethanol with some with proper value up to 29 millijoule kilogram per joule per kilogram. This is saying that was the most important is Sedamus dimorphus are the best according to this researcher, and this is going to after 60-70% can be is the highest, so high efficiently more than others. Then is using this method, and the most biggest is the highest yield was by chlorella using three. This is a hydrothermal special case as ever done is telling all the chemical. However, due to high temperature, which is 121, and use of initial acetic acid diluted, this is more hydrothermal method than hydrolysis only. So this is the 21 called another, but this is 30 degrees is going or 0.04 bioethanol per gram of waste. The also very is important is also giving for of chlorococcum, which case in 160. So again, hydrothermal, no like early ethanol, is not giving so high efficiency like that. So here is again comparison of what was saying in work of fortification And this is saying that again, in case of for ethanol, similar photovoltaication, the hydrothermal seems to be best. However, mostly affecting is the equipment, which is highly designed. And now is telling about how to make biodiesel. And biodiesel is also known as fatty acid methyl esters. It's used usually by vegetable oil, but this can be for karanka and yarofa also very well produced. But microalgae and supplementation, like Professor Weg, Professor Praven Kumar for Ethiopia, Waleja University use is very important to, to process, in case of biodiesel, the fuel that will be less polluting in carbon monoxide and nitrogen monoxide than traditional, because this mixture, especially with nanoparticles, are important to make biodiesel similarly efficiency similar to traditional oil, and the trouble is that it produces still in most cases more monoxide, nitrogen monoxide, and carbon monoxide than traditional fuel. Therefore, this is the focus on biodiesel, and this uh, mixture with microalgae is a very important case, very important mechanism to reduce and to help make the biodiesel so efficient, even if the tank is partly burned. How is working? So we have how to make this biofuel for microalgae. Here we have microalgae that takes this carbon dioxide, and then this infiltration we use centrifuging. Unlike in ethanol, we don't have this centrifuge. It already come to pretreatment. Here we have no pretreatment initially. Firstly by centrifuging, sedimentation, and then by centrifuging we go to drying, and we perform dry mass. We have extraction, methanol, ethanol, using alcoholic, using usually succinate. Also, very important now kind, because succinate is much energy. Is going to microwave and extraction. It's very much, but little focus attention and weaker use, but it's very highly mostly promising. Therefore, after all extraction, we have again biodiesel synthesis by transauthentication or non-catalytic high temperature, but catalytic extraction reduce much less energy, making more proficient and beneficial process. Then solvent a biodiesel of 30 to 40 megajoules per kilogram, which is much higher than ethanol, double higher than bioethanol in uh, higher heating environment. So the only other way is that in case of torrefication, we have better use and give some algae very good as for heating as for torrefication. But then I will tell more. And this biodiesel production, according to the Morse is supercritical reaction technique, extraction is by supercritical methanol, so very high. The biomass parameters is wise wet biomass given by high water hydrolysis or thermal hydrolysis, because 300 Celsius, 30 minutes, and methanol hexane as extraction as solvent, and then extraction. This gives us biodiesel conversion even 99%, but supercritical can require very specific and very strong material of the reaction. Therefore, ultrasound systems become less energy and about 80% maybe will be made. Also very promising microwave assistant, but also methanol and uses for 86. So we need to find why this supercritical methanol is so nice. And these factors used to microwave assistant to reduce so much energy needed and strength for making more suitable for common usage. Therefore, my biocrude oil, which is similar, using especially here is hydrothermal liquefaction, is using temperature conducting 350 focus of rocket. It's similar to biodiesel production, but bio-oil is conversion to using more chain and using also improving biocrude by catalytic hydrotreatment techniques. And usually bioalkali catalysts are needed, so quite easily turn on the poisoning. Here is similar to using, so centrifuging, so first like using, but some more solvent extraction double. So solvent recycling, and but because solvent is high, and hydrothermal liquefaction and hydrotreating, and have similar to use, but then can be used as automotive and be used in industrial biofuel. The microalgae is 10 to 20% is Switzerland fittings, a special case of separation extraction used for special mixing and twisting because is using this hydrothermal liquidated use preparation and extraction and dissolved recycling. Also is one way batch reactors and other way by using with catalytic hydrotreating. The switch range long is using packing to remove these reactors to reduce effect, and this is the other way. The highest biocrude yield was checking for stroke Kyoku species 350 and 60 minutes of hydrothermal liquid conditions, and solid content was 15. And this is the highest. And then was liquefaction for fire and liquid. And next is using how to produce biojet fuel. Biojet fuel is using kerosene obtained by to obtain is the upgraded kerosene obtained from post distillation. Jet fuel is mixture of paraffin. In case of another important is fuel energy density. Currently, fuel is switched from hydrotreated esters and fatty acid. The potential pathway is shown, and using the case is using palladium carbon catalyst, and these cabs, which are quite expensive, but this allows to use to transfer during pretreatment in 350 and 55 hydrogen pressure to produce. And the way is using here. First, we cultivate these microalgae, separate by filtration, sedimentation, and coagulation, centrifuge. Then we have hydrothermal liquid as earlier. Some is given some hydrogen to make more unsaturated fuel for unsaturated fats, and this is covering the solvent distillation, and then by a crude obtained by hydrogen addition. So we here see how we can use this hydrogen duct fermentation, which obtain in other methods, to produce upgraded, and then we get hydrocarbon C8C16 by mixture, which is suitable for bioaviation fuel. So we have, and is used by some experimenters in Japan and USA and Canada, and even was suitable because such fuel has better energy density to Canada in very cold regions, becomes more suitable than traditional fuel. So this is very important, and this is saying that highest the yield was for Hollerta, not but for Tuchus, even 76 of 78, but if hydro treated in using nitrogen nickel catalyst, and in case of cholera we use molybdenum oxidase catalyst, also nickel oxide. So nickel oxide is base in this case at after temperature of 410 and 50 bars pressure, so high pressure, and we need to make maybe some microwave will be suitable here. And now we have biomethane, so production by using anaerobic digestion. So this is also polyalkoxylate, but very much slower. So we have centrifuging, pretreatment, and going to anaerobic digestion, which is biosynthesizer. It can be used for more for recovery of metals, even heavy metals, and more of some extraction method for astaxanthin. So many by this way can be removed from these plants, and is by analogizing biomethane, and also give that by scrubber and use some pathway that scrubber can remove some carbon dioxide for better biomethane production, and this carbon dioxide can be from dry ice. This is the potential pathway which Professor Al-Jabari, Professor Al-Jabri proposed in case of biomethane. And hydrogen is similar because biohydrogen is produced here by algae, usually by documentation we see for production that anaerobic digestion but blocks this methane production by treatment of bacteria. However, this can be algae biomass can produce initially by splitting water, and then can be mixed dark fermentation with photofermentation to produce higher yield. Of course, there are thermophilic and mesophilic in country to suitable region. The most commonly facultative are Asterobacter, Escherichia coli, and then can be Clostridium as strictly material. So we have again cultivation, harvesting, centrifuging, pretreatment technique that can take, and aerobic digestion that produce hydrogen. The case is that is most complex because if we have photofermentation and fermentation, dark fermentation, this is to be split, and also is much more the spread-treated sterile needs to be very often, and this has some limitation, and what is not used for hydrogen can be used, moved to other substitution for technology, and this he give the highest production. If that pH needs to be acidic, they don't use here show, and here as the highest production uh, of using hydrogen gives a chlorella with 121 treatment of bacteria with reduced hydrogen acid. This produces pH 7. So this is by mix. Here, this work because it's not only was on dark fermentation, but it was mixing of dark fermentation and photofermentation here. So this is that all techniques are needed. Also, there is mention about economics advantages, and we have economically that most is given by operation costs. So how to build such system and how how to work operations, so how to keep it fit, and how to sell this natural operating costs, and give that still natural is only 9% due to high cost of operational, and that needs to be reduced. Cost of distribution gives that according to plant is 46. In case of microbial feedstock is the biggest of treating high that complain, so keeping this microalgae in proper conditions is a big trouble and needs to be used, reduce much cost to be suitable, because for example microalgae is 4 times higher than waste for hydrogen production, for waste than using, and needs to be more suitable, different. If you want to microalgae to make it profitable, we need already to make all possible potentials for biopolymers for using, and this is the key challenge here. And we have how to invest. This is the big trouble here. So those are the challenges. So thank you very much for listening to me.